Alright, so today we're going to be taking a look at the differences between rational and irrational numbers. Alright, so we've had to discuss this before when it came to writing these numbers as decimals and fractions, and that is a big indicator of which one number is. So here's a list of rational numbers and irrational numbers. So let's look for some commonalities and differences. First of all, if you look for regular whole numbers, you'll only spot them on the rational number side. So there's no simple numbers over here in the irrational column. So whole numbers and integers, negative as well, appear to be rational numbers. On this side, we have pi, e, which is another special number like pi. Pi is, as we know, approximately 3.1415, and so on. E, I don't recall what E is. Let's take a look at a calculator. It does say E is located directly above the division symbol. If we press second, that is E. If we press enter, it's approximately 2.718, and so on. Alright. You might notice that this list has a whole bunch of numbers that have these ellipses or dot, the and so on symbol. Let's take a look at radical 2. Radical 2 is approximately 1.414, and so on. 0.333 and so on, not repeating, unlike this one, is on this list. So is negative 3.863 not repeating, meaning something else will come after this. We don't know what it is, though. We can also write these as decimals. It will help us identify more patterns here. We have 5 radical 15. That's approximately 19.364, and it continues. We also have negative 4 radical 5, which is approximately negative 8.944. None of these are repeating decimals. They are also all infinite decimals, so they don't terminate. That's what makes them irrational numbers. They're one of those two. There are those two things. They are non-terminating, non-repeating decimals. Whereas all of these are terminating or repeating decimals. 5 terminates, negative 6 terminates. Radical 9 is equal to 3, which is definitely a terminating decimal. 3/4 is 0.75. That terminates. Negative 0.35 also terminates. This is 5 times 4, 20. 20 definitely terminates. And this is a repeating decimal. These are repeating, unlike these, which are non-repeating. We don't know what comes next here. It could be 862, and so on. This could be 593. We don't know. But these repeat. Now, the technical definition of a rational number is any number that can be written as a fraction, which we know 5 over 1 is 5. Negative 6 over 1 is negative 6. This would be negative 35 over 100. 20 is obviously 20 over 1. 0.3 repeating is 1/3. Let's use a calculator to identify what 0.863 is repeating. So it's negative 3.863. I need several 863s here. Enough that the calculator will register that this is supposed to be a repeating decimal. Hopefully this is enough. And one more, why not? Let's write that as a fraction. And that is negative 3,860 over 999. That's also 3 over 1. So all of these can be written as fractions. So they consist of fractions, radicals that have perfect squares, terminating decimals, repeating decimals. So let's look at the technical definitions. A rational number is a number which can be written as a simplified fraction of integers. So all of these are fractions of integers, meaning positive and negative numbers. That includes integers themselves, fractions, perfect square radicals because they become integers, terminating decimals, because as we saw they can all be written over some multiple of 100, and infinite repeating decimals, which we've seen how we can write those as fractions. Irrational numbers are numbers that cannot be written as simplified fractions. That makes sense. If rational can, irrational can't. So non-perfect square radicals will all be non-terminating, non-repeating. Non-terminating, non-repeating decimals, and special numbers like e and pi. So this is kind of a good set of notes to have on this, along with the 2 lists above. You can pause the video and take notes on this if you'd like. Alright, so here's some questions. Are each of the following rational or irrational? What is 0.75 plus 1.55? If we use a calculator, we should get 2.3. Based on the definitions above, this would be a rational number. That's because this is a terminating decimal. Radical 3 plus negative 2. That one's harder to check. Let's find out. What is square root of 3 plus negative 2? That is negative 0.2679491,924, and then that continues. So this is a irrational number because it is non-terminating and non-repeating. It has several 9s, but they aren't following any pattern of any kind. All right. How about radical 2 plus pi? Oh, just to point out, this is a rational number and a irrational number. Together they made a rational number. Here we had a irrational number and a rational number. Together made an irrational number. These are 2 different irrational numbers. If we add those, let's try it. Using a calculator, we get 4.555. Almost looks repeating, but it's definitely not. 8, 0, 6, 2, 1, and so on. So this is irrational, because it's again non-terminating, non-repeating. 10 times 0 is 0. Now I don't recall if we specified whether 0 was rational or irrational. So this is the product of 2 numbers. This one is rational. 0 is actually also rational because it can be written as 0 over 1. So 2 rationals make irrational. Let's take a look at this. This is a irrational and a rational. If we multiply those, negative 3 times radical 8 is equal to another non-terminating, non-repeating decimal. So that's also irrational. All right, now the more interesting one. What is radical 6 times radical 5? Well, that's equal to radical 30, which is a non-perfect square. So this should be irrational, which we can see using a calculator. The square root of, the square root of 30 is equal to approximately 5.5 4, 7, 7, 2, 2, 5, 5, and so on. So it's a non-terminating, non-repeating decimal. Oh. Alright, now on to questions that are asked fairly often nowadays. Can you find two irrational numbers whose product is rational? Alright, so the best thing to do is to start with two numbers we can multiply. So, for instance, radical 5 times what would be a rational number? Well, a rational number would be a perfect square. So 5 times what would be a perfect square? Well, 5 times 20 would be radical 100, which would be 10, which is rational. All right. As would radical 3 times radical 3, and so on. Whereas radical 3 times radical 2 would not be, because that does not become a nice whole number. Now let's find two irrational numbers whose sum is rational. Now this is tricky. There's no evidence of this, whether this can be done or not, but there is no evidence if this is the only way to do this, but we can always take any irrational number and add it to its opposite, and it will equal 0, which is rational. All right, there's no evidence that there aren't two other irrational numbers that you can add to get a rational number, but these always become rational. This is known as the additive inverse. If you add any number to its opposite, it will equal 0. Now in this case, 0 is rational, so that would answer this question. We have about one more question, I believe. Alright, we're going to find an irrational number and a rational number such that their product is rational. Alright, so let's say we have radical, 6 times what would be rational. Alright, so if we multiply by radical 3, we would get radical 18, which is irrational, so that doesn't work. We could multiply it by radical, radical 3 wasn't rational, so that wasn't an acceptable possibility. Radical 9, so that would be radical 54, which is irrational, so that doesn't work. We can multiply it by 0, which gives us 0, so that would be rational. So 0 is helpful, as are negative radicals, for determining or creating rational or irrational numbers of your choice.